Hello, here is Michael Poulin. I'd like to represent you a Sib pattern designed to make the interaction between microservices robust. Why do we need it? Business tasks require microservices to interact because they implement business functionality. In the distributed environment, microservices, as any other components, may and can fail. However, business does not accept failed functionality. Thus, we need to maximize robustness of microservice-based solutions. Following representation addresses exactly this problem. Sib pattern comprises two parts, twin and sibling. We will consider the case 1 for twin and we'll analyze the situation which can happen with quite popular and well-known interaction type through the direct API call. Many people execute it and many people exercise it, but we have to figure out what might go wrong with that kind of interaction. We do not consider any network failure, but instead we consider the interface failure. That means that the microservice actor cannot establish connection to the microservice respondent, or the respondent service might fail internally, does not provide needed functionality, respond with data or something else. Something going wrong and it is fails. Number of instances in the network doesn't help as well, because if the problem inside the microservice, not in the network, multiple instances would not help us with the solutioning of our problem. So what can help us is probably a few existing patterns. For example, multiple try microservice actor may multiple try to connect to the microservice respondent, or fallback, pause and try another pattern, or even circuit break. But what if none of them helps us to establish communication and get the proper result from microservice respondent? What to do next? We can look up at the different way of communication based on the event bus. In this case, we think that microservice actor fires an event to the event bus, which in turn propagates the event to the microservice respondent through the push mechanism. It's also a legitimate pattern. Many people use it and it also works fine, but let's see what might happen with that. Event bus fails. We don't know what's happened inside, but it does not propagate our events, it doesn't accept events, does not confirm acceptance of events, and so on. Another failure may be in the listener. Listener does not work, doesn't accept events, and microservice respondent cannot get event and act on it. Another situation, the failure inside the microservice respondent itself, as I said before, and it is a situation where we cannot use this microservice at all, but what we will be using instead. This is exactly the case where the Sib pattern can help. And that help is based on that every microservice in the pattern implemented solution knows that every other microservice has its twin. Twin is another independent microservice which has exactly the same API, the same functionality, and the same outcome, but implemented differently than microservice respondent. Since microservice actors knows about existence of the twin upfront, it does very simple thing. it tries to connect to the interface of the twin. And it is again direct API call. Actually, event bus has to be aware about this twin as well, and in this case it can do a very simple thing. It can forward the event to the twin if all its attempts to communicate with microservice respondent failed. Very well. We have a failover at runtime. However, what if in particular situation we have not implemented or deployed the twin? Like this, there is no twin for us. So what can we do? In this case, we use the second part of the Sib pattern, and this part is known as Sib pattern sibling. Sibling is just another microservice developed by somebody, we don't know who. It's totally external for us microservice. It has different API, different functionality, and different outcome, but it can return data that include data our actor is needing. That's the point. So actor knows about that upfront, and it can execute exactly the same thing. It can connect to the interface of the sibling, as well as event bus can do the same thing and contact the sibling the same way as before. As a result, we have two runtime failover options depending on the situation we are in, and this is not related to the network failure. It's related to the permitted failure of the microservice itself. There may be many different reasons we don't care about them, but we have to solve them. We have to make the communication between microservice actor and microservice respondent robust, and this pattern solves the problem, practically solves the problem. There may be different type of events, and we will talking about them in a different presentation, but for now, this is all what I wanted to tell you today. Thank you very much, and please consider my domain with more information about the subject. Thank you very much, and goodbye.